Hello everyone, we are looking at question 37 of grade 2011 chemical engineering paper. The question is, oil at 120 degrees Celsius is used to heat water at 30 degrees Celsius in a 1-1 co-current silent tube heat exchanger. The available heat exchanger area is S1. The exit temperatures of the oil and water streams are 90 and 60 degrees Celsius respectively. The co-current heat exchanger is replaced by 1-1 counter-current heat exchanger having a heat exchange area of S2. If the exit temperatures and the overall heat transfer coefficients are same, the ratio of S1 and S2 is dash. So in this question, initially we are considering a co-current silent tube heat exchanger for which we have been given the inlet temperature of the inlet and exit temperature of both the hot fluid as well as the cold fluid. Later, we are replacing this co-current heat exchanger by a 1-1 counter-current heat exchanger, and we have to find the correlation between the heat transfer area for both the cases if the exit temperature, inlet temperature and the overall heat transfer coefficients are same. So let's just consider first this co-current heat exchanger. Tube side will enter from here and exit from here. Similarly, the cell side fluid will also enter and exit from the same direction. Let's draw the temperature profile over here. So this is the hot fluid for which the temperature will decrease, and that we have been given as 120 degrees Celsius to 30 degrees Celsius. Similarly, the temperature of the cold fluid will increase. Direction of both the fluid will remain same, and for the cold fluid the exit temperature so the oil is used to heat water at 120 degree. Oil at 120 degrees Celsius is used to heat water 30 degrees Celsius. So the inlet temperature of water is 30 degrees Celsius, and for the hot fluid it is 120 degrees Celsius, and the exit temperature we have been given as 90 for the hot fluid and 60 for the cold fluid. And for this case we are having the heat exchange area as S1. Now let's calculate the log mean temperature difference for this case. That is delta T LMTD for the first case will be delta T1. So delta T1 will be 120 minus 30 is 90, and 90 minus 60 will be 30. So LMTD will be 90 minus 30 upon ln of 90 upon 30. So this will become delta TL1 as 60 upon ln of 3. Now we are replacing this heat exchanger by the counter current heat exchanger. So that is for counter current HE, the flow direction will be as mentioned in the figure. Tube side fluid will enter in the same direction, whereas the cell side fluid will enter in the opposite direction. And if I had to draw the temperature profile, then it will look somewhat like this. So this is 120 and the exit temperature will be 90, and for the cold fluid it will enter in the opposite direction. The inlet temperature is 30 degrees Celsius and the exit temperature is 60 degrees Celsius. And the heat exchange area is S2 for this case. In earlier case it was S1. Now we will calculate the log mean temperature difference for this case, that is delta TL2. So delta T1 over here will be 60 degrees Celsius, and at the other side it will be 60 degrees Celsius. So since this delta T is same, that is 60 degrees Celsius for both this inlet and exit, the log mean temperature difference we can straight away write it as delta T1 or delta T2, that is equal to 60 degrees Celsius. Now we have to find the correlation between heat exchange area S1 and S2. Now that is, we can, for any of this heat exchanger we can write Q as M1 CP1 delta T. If this is cold for cold fluid, then similarly for hot fluid it will become M2 CP2 delta T, and this will be equal to U1 area. Let's just consider it for counter current heat exchanger, so the area was S1, and delta T LMTD, that is delta T L1. Now for both of these cases, the cold fluid inlet and outlet as well as the hot fluid inlet and outlet temperature will remain same. The other parameters such as the specific heat and the mass flow rate are also considered to be the same. So basically for both of these heat exchanger, the heat exchanged by either the hot fluid or cold fluid will remain same for both this co-current as well as counter current scheme. So from that we can write this as US1 delta T1 is equal to US2 delta T2. So here it is log mean temperature difference delta TL1 and log mean temperature difference delta TL2. The overall heat transfer coefficient also we have been given it as same, so that is U will remain same. So from this we can find the ratio of S1 upon S2 that is required in the question. S1 upon S2 is delta TL2 upon delta TL1. So basically it will become 60 upon ln of 3. So this will become ln of 3 and the value of natural log of 3 will somewhat around 1.1. So from the given options we can select the correct answer as 1.1. That is, if we are changing the scheme from co-current to counter current, then the ratio of their heat transfer area will be 1.1.